What's going on?
Yes, good.
It's going?
We have, yes. It's fine.
Okay, so I turn off YouTube. Okay.
Right.
Do you see it?
One, five,
Okay.
with some delay maybe 7 seconds delay. Yeah. Where do I have? Where do I have?
To kiedy wszystkich telewizjach przeczyta reprezentanci Polski, nie? Z Terenowej do Tarczyński, bo ja nie trzeba odwrócić.
How can I make it here on my side or not possible? Possible? It should be possible.
Proszę mi jaka jest
No, like you have the.
Yes, yes, I know. It's not possible.
Like, view. View. Ah,
Maybe this.
you remember you had this on one side.
You need to try this dots.
Jakie to daje? To jest 10 kroków. Nie wiem.
No to co? Co mam na zegarku? 4 minuty. Tak, moi drodzy, to jak tam mnie słychać na transmisji? Już rozpoczęła się?
Tak,
Popierajcie pani Anisję.
Yes, yes, I accept.
Jest dużo.
Tymi tutaj trzeba nacisnąć.
No, to jest przyjęta
No to dobrze. Bo wyświetlę się, że tak. No cóż. Cias. A gdzie mój cias? Tutaj nie wyświetlę cię. Pomniejszy. Jeszcze 3 minuty.
57.
Dobrze. Powiedzcie kiedy.
Tak, tak.
Tak.
Jeszcze minutka. Ostatni oddech. Nie, 2. I będzie 5.
Katowice robił Silesian.
Ja, to.
Okej, to co? Ale blisko.
Poczekajmy na youtuberów.
No. To będzie jak telewizja.
No,
Jak najbardziej.
robimy telewizję.
Yes. Okay, dear colleagues, this is very nice for me. Say that now we begin our very important event. I maybe in my presentation say something about this, but today we have scientific symposium of young researchers with a mutual title transport problems. This is 14th time we have this symposium, and our conference is a part of this event. We have 17 times. And I maybe explain you some of our mutual principles of these events. Traditionally, we have here 3 main conferences languages: English, Russian, and Polish. Therefore, all our participants can make their own presentations. Slides must be only in English, but say something, explanation about the slide, of course, in this one of these 3 languages. Therefore, I now explain in Russian. Мы на наших событиях, которые состоят из 2 частей, из симпозиума молодых ученых, который 14 раз собирается, и конференция, которая будет уже 17 раз, имеем главные принципы. Здесь есть 3 главных конференционных языка: английский, польский, русский, и слайды должны быть у всех участников были подготовлены на английском языке, а уже пояснения могут быть даны на любом из данных 3 языков. I don't speak this in Polish language because many Polish participants know about these principles, and now I explain something in my presentation, please. Now, because when we begin this presentation, maybe I explain you that in this first session of our symposium, the chairman is Pani Maria Cieśla, doctor habilitate, and of course I ask you, Maria, looking exactly about time of our presentation. This is very important. And now I maybe explain you something about this, our events. These events beginning from our journal, because this journal begin own work in the year 2006, and now we publish volume 20. You believe? This journal have many editions, you can see, and in this Excel of the time, we can look that from the year 2012, this is part of the Scopus database. And from the 2017, this is indexed in the Web of Science. And when we have this journal, you can look now our authors is from 60 countries. But reviewers, we have much more, 80 countries. And if we have so good journal, near this journal, we organize our conference. This was the idea that organize conference with the same title. This is very important and useful because now maybe I explain you in our conference and symposium, we have 115 papers. This can be published in our conference proceedings. But best of these papers can be sent to our journal, and therefore we have opportunity to have this choice. And another principles, very important, we organize this our conferences every time, every year in different places. You can see this for first conferences is our cycle. Next fall, you can see in different and other places. Next conferences was in different places, except conferences this time. We have the terrible situation with the COVID, and therefore we have firstly organized our conference in the online regime. But after that, we decided that all conferences must be in mixed form, online plus direct, offline. This is very useful, therefore we now have our participants practically all over the world. Many our participants can use this opportunity and present own presentation using internet. And this, in our symposium, we had the same situation. But after some times, we understand that maybe we have not only conference, but the symposium of young scientists, and this is the part of our event. And you can understand that always in our events, we have two kinds of our meeting. Of course, we have discussion at our sections, but our participants have opportunity to look some very interesting historical places in our region, you can see in this slide. And not only, but look something industrial companies which deals with the question of the present. You can see, for example, this is Fiat company. And now you can see this was geography of the first conference, only 12 countries. But if we can look during this time, we have 43 countries participants in our conference. And if we can look now statistics of these events, we can have 325 participants from 32 countries. You can look flags of these countries. Of course, we have symposium with 24 presentation conference at the Wednesday, 8 presentation and 8 special session of the main part of conference, 94 presentation, and total number of the speeches and reports, practically 140. And if you can look next slide, this is statistics connected with the publication. this publication can be published in conference proceedings, and you can see here is how much papers we can have here. And what is very interesting that average number of pages per article, we have much more. And this is very good because we have not thesis, we not publish abstracts. We publish here in our participation only full papers. Only you must understand that please not try personally publish this is in internet, because if scientific committee of our conference decide publish this paper in the journal, this can be contrary with the questions of the plagiat, auto-plagiat. Therefore, only wait for decision of our scientific committee. And now, some propositions for you. You can see that in scientific seminar in the world, traditionally, this is only one day. Scientific meetings or symposium, we have 1 or 2 days. Conferences, 2 or 3 days. And scientific congress from 5 days. Of course, congress and conference have special events, but we have proposition for you. From the next year, we can organize with the neutral title International Scientific Congress Transport Problems, which can consist from 2 parts. Traditional parts, scientific symposium and conferences. And if you have now, because now practically we get this congress, but we have not this title, maybe from the next year we can organize this congress. And now we must understand where we can find next place for these events. Now we can organize this symposium, you know, can be in Katowice, Gliwice, our conference in Katowice, Wisła, after that, Žilina and Gliwice, therefore many places, very interesting. And now we must decide, I want to listen your propositions from the next year. Thank you for attention, and you can contact with me or our organizers. Thank you.
Thank you, Professor. So whenever we will have any questions with the scientific issue, we will contact with Professor.
Yes, I all times are here. And if you have sent another questions, of course, you have all my mail. You can send me by mail all questions. I try answer you. Thank you.
Thank you. And now we want to also have some information about organizational issues. So I will ask Professor Grzegorz Wojnar, who he's the chairman of the organizing committee, and will give us some additional information.
Ladies and gentlemen, Jeszcze raz.
Maybe say something. Yes.
Ladies and gentlemen and dear friends, I would like to welcome everyone gathered at the symposium. My name is Grzegorz Wojnar. I'm the chairman of the organizing committee. The members of the organizing committee are with us here and online. The conference time is time in Poland. Presentation time is 10 to 12 minutes. Maximum after 15 minutes will be a new presentation. We ask that the camera is turned on only by the person who were given the vote. A vote may be given only to the person who raised their hand by Zoom communicator option or traditional or stationary participants. Będę potrzebował teraz dalsze slajdy. In near future, we have two sessions, number 1 and number 2. Next will be lunch at the Academy of Music for stationary participants. After the lunch, we come back to the faculty and will be two sessions, number 3 or number
the program, you can participate in all events which we prepare for you in the frame of this symposium. Okay, thank you.
Thank you. Okay, so this is the first session of CC. We have to go through all the technical issue, organizational issue, but welcome to the first session of the 14th Symposium of Young Researchers. I will be the chairman, and we have 5 presentations for this session. 3 will be done in place and 2 will be done online. So the first presenter is Stefan Wagebeck, who wrote the article with Mr. Grzegorz, and the title of the presentation is Electric Heavy Duty Powertrain Tractor Characteristic Analysis and Performance Improvement. So I will ask you to present your paper. You have 15 minutes. If we do it in less, then we can go through questions.
Okay, thank you for if you have any.
You have the first question.
It's a great honor to begin this session with the presentation. The presentation consists of a short introduction to research, statement of the research object, the touching characteristics, and the performance improvement we've done, our research object, and then I will sum it up with some conclusions. The reduction of CO2 emission were the main topic of researchers in the last years in the area of transportation. And this has led to the electrification of both passenger vehicles, but also heavy duty vehicles and buses. But also some European countries are supporting somehow the market of electric vehicles by introducing, for example, toll tariffs dependent from the CO2 emission class of the vehicle, like Austria and Germany did in the last years. But also some cities introduced the zero emission zones. That means that in these zones, no conventional vehicles can drive around. And in January this year, Amsterdam has introduced this zone in their city. But Amsterdam is not only the only city which wants to introduce this kind of restricted areas. Also, 28 other cities of the Netherlands, Paris, London, Copenhagen, wants to introduce these zones till 2030. If we look at the researches which were about heavy duty vehicles, we will mention that most of them were about the batteries or the fuel cells. There are not many researches based on the powertrain itself. We previously conducted some research which consisted of the analysis of traction properties of a heavy-duty vehicle with a total mass of 90 tons, like this one you see now. And we were actually a bit curious of how it would be in case of a vehicle with a total mass of around 40 tons, which actually is holds the main market share in Poland. So we decided to conduct similar research to our previous, but this time we choose for a semi-truck. It was a CF model. The truck has 2 variants of a powertrain, one with a conventional engine and one with an electric engine. the technical data of these engines were quite similar. If we look at the charts presenting the motor characteristics, we will see that the electric motor has a wide range of operational speed opposite the conventional engine, and this had caused that the conventional vehicle has to use gearbox existing of 3 main gears, the splitter group and the range group, which altogether provides 12 different speeds. Let's go to the traction characteristics. On this chart, you will see the propelling force of the vehicles. And the propelling force of the conventional vehicle for the first 2 or 3 years is above 100 kilonewtons. And this caused that we were a bit worried about if we maintain the condition of adhesion of the drive wheels. So we calculated the maximum torque value of the engine which can be used on a particular gear. And for the first 2 gears, it came out that we have to reduce the maximum torque value of the engine of the conventional vehicle. We also made a simulation of the vehicle's speed change, which made it possible to determine the maximum speed of the vehicle and to estimate the time in which the speed of 80 kilometers per hour will be achieved. And on the graph on the right, you'll see the maximum speeds on slopes, and it shows that the electric vehicle has is less able to overcome steep slopes like the conventional vehicle. And the main conclusions still now are that the maximum speed of the conventional vehicle is 101 kilometers per hour, and for the electric vehicle it's 82 kilometers per hour. If we use the peak power, then we can achieve the speed of 89 kilometers per hour. Also, the time in which the speed of 80 kilometers per hour is reached is much longer for the electric vehicle. It's 177 seconds, and in case of the conventional vehicle, it's 102 seconds. And the maximum slope of for the electric vehicle is 6% for the continuous power and 12% if we use the peak power value. So we decided, we have seen that there is some area in which we can make some improvements in this, especially in case of the gradability of the vehicle. So we decided to modify the drivetrain by adding a gearbox to the system and changing the gear ratio of the main gear. The first gear of the gearbox provides the ability to overcome higher slopes, and the second makes it able to reach a bit higher maximum speed of the vehicle. So we again calculated the maximum torque value of the engine, and the condition of maintaining the adhesion is achieved. So the results of this are that we have a bit higher acceleration in the range of from 0 to 40 kilometers per hour for the electric vehicle, and the gradability was also increased almost twice, because previously we had maximum 6% gradient of the slope. Now we can drive over the slope with 12% gradient. And the main conclusions are that adding the gearbox is essential for electric vehicles with high payload, where the payload can exceed the vehicle mass itself almost twice. And we actually analyzed 6 different cases of combinations of the gear ratios and also the number of gears. And one of them showed that we can shorten the maximum the time of reaching 80 kilometers per hour of the electric vehicle by 51 seconds. And this also shows that all the different cases we have analyzed can be assigned to a given vehicle application, depending on the specific tasks and work conditions of the vehicle. And selecting the right drive system is essential when changing the electric motor or the motor propelling the vehicle to provide the right values of the most important traction problems. And in the future, well, we will focus on the change of energy consumption and the possible ways to reduce it based on the system. Thank you for the attention. If you have any questions,
Then we
try
will
to-
later because we have no time for that. Sorry. Thank you, Stefan. I'm in the region of the time, so perhaps if we have any questions, we can do it at the coffee break or later if we have time. Okay. I hope you don't mind, Stefan. Okay, the next presentation is from our colleagues from Japan. I will try to announce it. It's Young Adishamfu Harume, and here I will be presenting the paper, which title is Intergenerational Transport Habits and Children's Mobility Choices, a study of car-dependent households in Malaysia and public transport-oriented households in Japan. Do we have the presenters online?
Yes.
Okay,
Hello.
we can hear you, we can see you.
Mhm.
Please take 15 minutes to present your presentations.
Okay. I will share my slides.
Yes, we can see you.
I cannot share my slides.
We have shared it. You can see it.
Oh, okay. All right. So you will share on behalf of me. Okay. Okay. Thank you very much. So very good morning, everyone. I'm Adila from University Malaya, Malaysia, and I'll be presenting our joint research paper with Dr. Sohana, Dr. Sasnizam, Dr. Rida from University Malaya, and our colleague from Fukuoka Women University, Japan, and also from Waseda University. So this study actually examines how parental travel behavior influence children's future transport preference in Malaysia and Japan. Okay, next. Actually, children transportation choice are largely shaped by their parents. Whether you decide to drive or you decide to walk or using the public transportation, these choices are actually influenced not just by the infrastructure, convenience, or culture, but also based on the long-standing habit. So our study actually wants to see how does the exposure from on the children's future mobility decision. Next. The transportation habits are automatic behavior developed through repetition. That means that parents who really driving their children to school will make the car travel by default. And even when the public transportation is readily available, the intention to use the car is a very high chance. So next. Our study actually grounded by the theory of planned behavior, TPB. So in this theory actually suggests that the emotional response, the social norms, and also the behavior control shape our choices. And the transportation habit, especially those involving children, are actually strongly influenced by these psychosocial drivers. And in contrast, our study actually study more than just a single layer than what TPB framework by applying it across generational lines. That means not just to the parent but also to the children. So we look into how parents transport related attitudes, the perceived behavior control, and the normative belief, whereby the children's familiarity, whether they are confident when they using the public transportation, and the long-term mobility preference. So we highlight that transportation habits are not formed in isolation but are actually socially and psychologically modeled and observe. All right. Next. So even when parents recognize the benefit of public transportation, emotional comfort with private car use often dominates. This effective pattern complicate efforts to promote the use of sustainable transportation, especially in developing countries like Malaysia, whereby traffic congestions and the use of private vehicle is very high. So strategies to change the behavior must target the psychological underpinnings of these choices. Next. So children internalize parental behaviors, and parent who says walk to school but always drive sends conflicting messages, and consistent modeling like walking or taking the bus help build children's confidence like what we see in Japan. So next. In Japan, through our collaboration with the universities in Japan, we understand that the community participation plays a key role, and the volunteers often help children. It can come from the elderly citizens or even the parents who are not working, or parents who are working but taking an alternate um, holiday from work, help children to cross safely when they are going to school every day. So this reflects the importance of social and familial support in promoting walkability and independence in Japan. So next. So what we have here is we collect data from 120 children through an online survey. We what we got is 104 children from Malaysia, aged 13 to 17 years old, and we able to get 16 from Japan, and we use a purposive sampling to gain a context-rich insight. And although from the sample that you can see, the sample size from Japan is smaller than the Malaysia, because it is not comparative study, it's more of a lesson learned. It still offers a valuable cross-cultural perspective. Next. So the sample leaned toward female respondent actually, and nearly all Malaysian family reported they have a car. To support this study, we have like 32 million population in Malaysia, and the ratio is that each member have a car. So these affirm the dominance of car culture in Malaysia and help us understand children mobility within that environment. Next. Our structured questionnaire focus on four constructs. We have the parental influence uh, uh, on the first part of the chart, and then we have the perceived barriers and the familiarity and confidence of the children, as well as the future leading to the future preference of children who answered our questionnaire. So these were adapted from validated tools and which is based on our literature review and the theory of planned behavior that we have before. Next. So in these two slides, we are sharing the structural equation model as a result of using the analysis using the PLS-SAM. So in this model, we hypothesized and tested how parental influence, which is the top part of the model, and also the perceived barrier shape children's familiarity with public transportation and their future preferences. So we use the PLSM to test the structural relationship among the four key constructs, as I mentioned, and the all measurement items showed the reliability and also the validity. Next. So the first model was showing the total result of Malaysia and Japan, and the second one only on the Malaysian result. So next. So based on both result, we can see that the Malaysia car use is very dominant, and in Japan, public transportation is normalized. So we aim to understand how parent choice shape children's long-term mobility attitudes. Next. So previous research conducted by Verplanken and Arts showing that the habit formation depends on the repeated behavior. Okay, next. So if you can see here that the habits which are mentioned by Verplanken and Arts showing that the automatic behavior is also by the repetition. Next. So this is a very disturbed graphic showing that children at a very young age was caught driving recklessly using their parents' automobile with the parents knowing that this situation happened. And this is a very what you call that not a common behavior. However, the exposure of children towards the idea of driving car has started as early as 5 years old. Next. So we tested the relationship among four latent constructs, as I mentioned before: parental influence, perceived barrier, familiarity, confidence, and future preference. So the framework allows us to evaluate how does the habits are transmitted intergenerationally. Next. All right, so I have mentioned about this use. Okay, next. All right, so the sample, as I mentioned, is between 13 to 17 years old. All right, next. I'm going to skip a little bit. Next. Next. So when we look into the structure model of the Malaysia data set, that we can see that the higher car dependency is very high compared to and having parental influence are stronger. Next. This confirmed the role of social modeling that occurred in Malaysia. So when we see the result of the R variance, where R value actually show how well our model explain the variance in the outcome, we can understand that the result showing that 0.478, that is 47.8% of the variance, explain that the parental norms and parental influence actually leading to future preference of the children. Next. So the summary of the data that we have analyzed using the PLSM statistical method, that we can understand that in Malaysia there is a strong parental influence in the idea of driving personal vehicles, or having normalization in using the personal vehicles instead of public transportation, where while in Japan we can understand that among our sample, the early independence and institutionalized support, which includes the elderly support to take care of children while walking to school, is very strong. So in Japan, we can understand that the cultural context moderates with the support of parental influence. Next. So in terms of policy implementation implications, we can understand that Malaysia needs improved pedestrian infrastructure, mobility education, and the pro-public transport narrative. And Japan shows how institutional support and community programs can foster independence from the early years, like what they have already have right now. Next. So as conclusion, we think that our findings suggest that the theory of planned behavior can be effectively extended beyond the individual decision making that is the parent themselves, and understand that there are some influence on the intergenerational transport habits, like what we can see in Malaysia. So children's future transportation preference significantly shaped by the model attitudes, perceived barrier, and the behavioral norms of their parents, highlighting the need for policy intervention that must target the family-based behavioral change instead of the larger community. So, transport choices are intergenerational instead of a single individual. So, parents modeling early exposure and supportive infrastructure must be combined for long-term sustainable behavior. Thank you very much. So, I would like to thank the university for supporting this conference funding and my colleagues from Japan for the data. Thank you very much.
And you maybe some questions from my side.
Yes.
You will listen.
Yes.
Now I'm looking for your presentation and for your paper, because I'm editor-in-chief of our
Yeah.
journal, and I think that this is very interesting topic. But this is questions not only for you but for all participants. When I am looking the list of the citation of the in your journal, I find many positions from the last 20th century. This is not so good, because you discuss in your paper, in your presentation, modern questions, because positions from the comparatively huge age, this is not good for a reviewer which try analyze your therefore, if you want to participants in our journal and publish your work, please looking through your work, your paper, from the point of view modernization of the references in your work. Yeah.
Okay.
Thank you. And I ask you only why, because this is connected for all participants and for our future authors. Looking, please, to your works from this point of view. Yes, thank you very much. You have very good presentation and interesting. Thanks.
Thank you, Professor.
Thank you, Adina. Any other questions? Okay, no other questions from the audience. So we will move on to the next presentation. And the next presentation will be presented by Paulina Szpieg. And this is a presentation with Anna Grana and Wieta Macieszek and Aleksander Sładkowski. The title is Impact of the Implemented Railway Investment Related to the Reconstruction of the E65 railway line in Sosnowiec on the operational of the selected bus line in public transportation. Go ahead, thank you.
My name is Paulina. I will present in Polish, so przygotowałam artykuł razem z panią profesor Anną Graną, Wietą Macieszek i Aleksandrem Sobotą. Pokrótce przedstawię plan prezentacji. Najpierw przybliżę, jaki był cel naszych badań. Później wspomnę o zakresie inwestycji związanej z przebudową linii kolejowej A65. Następnie wspomnę o wpływie tej inwestycji na publiczny transport zbiorowy, na funkcjonowanie publicznego transportu zbiorowego. Następnie przejdę do analizy danych eksploatacyjnych wybranej linii autobusowej przed i podczas prowadzonej inwestycji. Następnie przejdę do analizy potoków pasażerskich na tej wybranej linii autobusowej przed i podczas inwestycji, a na końcu przejdę do wniosków. Celem artykułu była analiza wpływu prowadzonej inwestycji kolejowej w Sosnowcu na funkcjonowanie wybranej linii autobusowej w publicznym transporcie zbiorowym. Cała inwestycja jest podzielona na 2 etapy. Pierwszy etap to jest A1 i to jest odcinek między Będzinem a Katowice Południowe. Podczas tej inwestycji zbudowane zostaną dodatkowe tory kolejowe, wybudowane zostaną dodatkowe 2 nowe dodatkowe przystanki kolejowe i to będzie przystanek Sosnowiec-Śródula zlokalizowany przy ulicy Chemicznej oraz Katowice-Morawa zlokalizowany przy ulicy Morawa. Dodatkowo przebudowane zostaną perony na stacji kolejowej Sosnowiec Główny oraz zmodernizowana zostanie stacja Będzin. Podczas inwestycji dla odcinka między Katowice Południowe a Katowice-Piotrowice zostaną również wybudowane dodatkowe tory kolejowe. Wybudowane również zostaną nowe przystanki kolejowe Katowice Uniwersytet Paderewskiego, Katowice Akademia, Katowice Kokociniec. Stacja Katowice-Brynów zostanie przeniesiona w rejon autostrady A4 oraz zostaną zmodernizowane funkcjonujące już stacje i przystanki Katowice Południowe, Zawodzie, Katowice Główne oraz Katowice Ligiota. Dodatkowo w ramach inwestycji zostanie wybudowane lokalne centrum sterowania ruchem, które będzie zlokalizowane w Katowicach i w centrum tym zarządzane będzie ruchem kolejowym na odcinku Sosnowiec-Ligiety. W efekcie przeprowadzonej inwestycji zwiększony zostanie poziom jakości transportu kolejowego na terenie aglomeracji. Będzie dostępnych więcej połączeń kolejowych. W związku z tym, że zostaną wybudowane nowe przystanki kolejowe, zwiększona zostanie dostępność do publicznego transportu zbiorowego. Prędkość pociągu zostanie podwyższona do 160 km na godzinę, co wpłynie na skrócenie czasu podróży. Poprzez wybudowanie dodatkowych torów odseparowany zostanie ruch lokalny, aglomeracyjny od ruchu dalekobieżnego i poprzez przebudowę przystanków i stacji kolejowych podniesiony zostanie poziom bezpieczeństwa dla pasażerów. Teraz przybliżę Państwu wpływ prowadzonej inwestycji na publiczny transport zbiorowy akurat w Sosnowcu. Prace są prowadzone na 4 przejazdach czy wiaduktach kolejowych. Pierwszy z nich to jest przejazd kolejowy na ulicy Chemicznej. W związku z prowadzoną inwestycją występują zawężenia jezdni na drodze krajowej 94, co wpływa na funkcjonowanie publicznego transportu zbiorowego poprzez konkretnie na linię metropolitalną M2. Dodatkowo w chwili obecnej zamknięty jest przejazd kolejowy na tej ulicy Chemicznej, co skutkowało z koniecznością zmiany trasy wjazdu linii autobusowej nr 116, która kursuje pomiędzy Sosnowcem przez Będzin do Dąbrowy Górniczej. Jeśli chodzi o wiadukt na ulicy, przejazd pod wiaduktem kolejowym na ulicy Nowopogońskiej, przejazd ten jest aktualnie zamknięty. W tym rejonie jednak nie funkcjonuje publiczny transport zbiorowy. Przejazd pod wiaduktem kolejowym na ulicy Żeromskiego aktualnie również jest zamknięty dla ruchu kołowego i pieszego, co skutkowało zmianą tras przejazdów 5 linii autobusowych. W chwili obecnej jednak przejazd tramwajowy pod wiaduktem na ulicy Żeromskiego jest dostępny po jednym torze. Jeśli chodzi o przejazd pod wiaduktem na ulicy Piłsudskiego w Sosnowcu, w tej chwili jest możliwość przejazdu, jest dostępny dla ruchu kołowego po jednym pasie w każdym kierunku. Natomiast w lutym Tego roku już na okres miesiąca zamknięty był przejazd pod tym wiaduktem. Najbliższe zamknięcie planowane jest jeszcze w tym tygodniu, chyba od piątku, z tego co pamiętam. I zamknięcie przejazdu pod wiaduktem skutkuje zmianą tras przejazdów 9 linii autobusowych funkcjonujących na obszarze Sosnowca. Na slajdzie przedstawiłam analizę danych eksploatacyjnych linii autobusowej nr 808 przed i podczas prowadzonej inwestycji, czyli przed zamknięciem przejazdu pod wiaduktem kolejowym na ulicy Piłsudskiego i podczas tego zamknięcia. Linia autobusowa nr 808 obsługuje 3 gminy Górnośląsko-Zagłębiowskiej Metropolii, Dąbrowę Górniczą, Sosnowiec i Katowice. Kursuje z częstotliwością co 20 minut między godziną około 4:30 do 23:30. Razem z linią metropolitalną M4 od Sosnowca Zagórza do Katowic kursuje ze wspólną częstotliwością co 10 minut. Zarówno przed zamknięciem przejazdu pod wiaduktem, jak i podczas do realizacji przewozów na tej linii wykorzystywane było 8 pojazdów. Linia realizuje 108 kursów w ciągu dnia i wszystkie kursy są realizowane taborem CN, czyli tym największym przebiegowym. Przed zamknięciem przejazdu pod wiaduktem linia realizowała 2928,5 wozokilometrów, natomiast po zamknięciu w związku ze skierowaniem linii na trasę objazdową praca eksploatacyjna wzrosła o ponad 318 wozokilometrów. Czas trwania kursów również się wydłużył, natomiast w związku z tym, że wydłużyła się trasa przejazdu, a nie zwiększyła się liczba pojazdów skierowanych na tę linię, czas przerw eksploatacyjnych dla kierowców uległ skróceniu. Prędkość eksploatacyjna, czyli jest to taka prędkość, w której ujęte są również czasy postojów na przystankach krańcowych, wzrosła o prawie 2 km na godzinę, natomiast prędkość komunikacyjna zmalała o 30 km na godzinę. Efektywność rozkładu jazdy, która jest rozumiana jako stosunek prędkości eksploatacyjnej do prędkości komunikacyjnej, wzrosła o 8,7%. 0,07%, przepraszam. Na slajdzie przedstawiono potoki pasażerskie na linii 808 przed zamknięciem przejazdu pod wiaduktem kolejowym na ulicy Piłsudskiego i podczas tego zamknięcia. Największe potoki pasażerskie rozumiane jako suma osób wsiadających do pojazdu realizujących przewozy na linii 808 zanotowano na przystanku Sosnowiec-Dworzec PKP. Przystanek ten jest zlokalizowany w centrum miasta Sosnowca. Zatem przypuszczam, że pasażerowie korzystają z tej linii w dojazdach i powrotach z tej dzielnicy. Przystanek autobusowy Sosnowiec 3 Maja Wiadukt to jest przystanek tymczasowy, który został uruchomiony na okoliczność zamknięcia przejazdu pod wiaduktem. Niemniej jednak przystanek ten nie był znacznie wykorzystywany przez pasażerów. Dodatkowo na przystanku Pogoń Aleja Mileckiego i Pogoń Grotaroweckiego widoczne są tylko potoki pasażerskie podczas zamknięcia przejazdu pod wiaduktem, ponieważ przystanki te były obsługiwane na trasie objazdowej i nie są obsługiwane na stałej trasie przejazdu. Najmniejsze potoki pasażerskie występowały na przystanku Dąbrówka Mała Nowosan, co już zostało na przestrzeni lat zaobserwowane przez organizatora publicznego transportu zbiorowego i dlatego też przystanek ten ma status na żądanie. Przejdę do wniosków. Zmiana trasy linii 808 skutkowała zwiększoną pracą eksploatacyjną. Dodatkowo wydłużył się czas trwania kursów, co jest naturalne w związku z wydłużeniem trasy przejazdu. Czas trwania przerw eksploatacyjnych został skrócony, co mogło wpłynąć i może negatywnie wpływać na punktualność kursów. W związku ze zmianą trasy przejazdu i wydłużeniem tej trasy przejazdu nie skierowano do obsługi przez linię 808 dodatkowego taboru, co może być spowodowane brakami kadrowymi i taborowymi u operatorów publicznego transportu zbiorowego. Największe potocki pasażerskie były zaobserwowane na przystanku Sosnowiec z PKP. Najmniej wykorzystywany przystanek autobusowy to Dąbrówka Mała Nowosan, o czym już wspomniałam. W związku z prowadzoną inwestycją i zamknięciem przejazdu pod wiaduktem kolejowym na ulicy Piłsudskiego zaobserwowane zwiększone potoki pasażerskie, co może sugerować, że jednak więcej osób przy prowadzonych inwestycjach i zmniejszonej przepustowości na ulicach miast decyduje się na skorzystanie z publicznego transportu zbiorowego. Dziękuję bardzo.
Do you have any questions for our...
Czy mogę powiedzieć, że prowadzenie inwestycji przez PKP sprawia, że transport publiczny jest alternatywą na współpracową samostatnie?
Patrząc na wyniki napełnień, wydaje się, że tak. Więcej ludzi jednak decyduje się na skorzystanie z publicznego transportu zbiorowego, co wydaje się naturalne w związku z tym, że trasa objazdowa, jeśli chodzi o trasę objazdową przy zamknięciu wiaduktu na ulicy Piłsudskiego, jest naprawdę ciężka do pokonania. Dlatego myślę, że zdecydowanie. Zresztą sama się również częściej decyduje na skorzystanie z publicznego transportu zbiorowego przy takich utrudnieniach.
Ja jestem pod wrażeniem tego, że pomimo utrudnień, które to stwarza dla państwa, to efektywność jest większa przejazdów. To jest niesamowite, prawda? Że tylko dać nam problem do pokonania i będziemy zwiększać efektywność procesów po prostu. Także bardzo dobrze, dziękujemy jeszcze raz.
Ale jeszcze jest jedno pytanie związane z tymi dwoma przystankami obok nas. Czy nie jest to już przesada, że odległość między tymi przystankami, których będzie Uniwersytety Akademickie, faktycznie dwa przystanki tramwajowe? Czy ma to sens?
No jest tego dużo, ale gdyby nie było przystanków, to nie zwiększylibyśmy dostępności. Jednak liczba pasażerów niekoniecznie by tak wzrosła, jeśli chodzi o pasażerów kolei. A taki jest nasz cel w tych połączeniach aglomeracyjnych.
Jeżeli człowiek chce dojść do przystanku w ciągu kilku minut, to być może to jest alternatywa, żeby ich przeciągnąć. Jak mają możliwość szybkiego dojścia.
No cóż. Oby.
Super. Dziękujemy jeszcze raz. Okay. And now we are moving online again with the next presentation. I would like to welcome Kuzada Mashapayeva, who will be presenting effect on sands sedimentation on well product transportation. Hello, Kuzada.
Здравствуйте. Hello. Добрый день. Разрешите начинать? Уважаемый председатель и уважаемые коллеги, разрешите мне представить доклад, который подготовлен мной вместе с моими научными руководителями. Доклад на тему влияния седиментации песка на транспортировку скважинной продукции. Следующий слайд. Next. При эксплуатации нефтяных скважин с глубинно-насосным оборудованием транспортировка добываемой продукции из пласта к поверхности сопровождается движением сложной многофазной смеси, включающей нефть, воду, газы и механические примеси, и в частности песка. Седиментация песка – это процесс осаждения частиц в столбе жидкости при понижении скорости потока или же при остановке оборудования. Этот процесс напрямую влияет на эффективность транспортировки продукции по основным следующим причинам. Первая причина – это абразивный износ и засорение рабочих органов глубинных насосов, нарушение непрерывности транспортировки. При остановке скважины или снижении скорости потока песок оседает в насосно-компрессорных трубах и в приемной зоне насоса, что вызывает его заклинивание и остановку процесса транспортировки жидкости на поверхность. Вторая из причин – это повышенный износ и коррозия резьбовых соединений насосно-компрессорных труб, рост гидравлического сопротивления. Скопление осадка увеличивает шероховатность и сопротивление в транспортной колонне, снижая дебит и повышая нагрузку на самом насосе. Третья причина – это риск образования песчаных пробок. Пескопробки затрудняют возобновление нормальной транспортировки после перерыва, нередко требуя подземного ремонта. Четвертая причина – это неравномерность распределения потока. То есть вследствие оседания песка происходит частичное перекрытие сечения потока, что снижает гидродинамическую стабильность транспортируемой смеси. Вышеуказанные причины в конце приводят к снижению эксплуатационного ресурса, оборудования и частичной установки скважины. Next. Поставленными задачами исследований является анализ процессов седиментации песка в условиях скважины и выявление факторов, влияющих на его осаждение, с целью улучшения режимов эксплуатации и повышения надежности глубин насосного оборудования, а также развитие инженерной диагностики и моделирования процессов, происходящих в условиях пескопроявления. В работе используются теоретические расчетные модели для оценки скорости осаждения песчинок в зависимости от их диаметра, плотности среды и вязкости жидкости. Также анализируются критические значения предельного напряжения сдвига, при которых частицы остаются в взвешенном состоянии. Next. При работе глубинно-насосного оборудования в насосно-компрессорных трубах формируется устойчивый восходящий поток жидкости, выносящий механические примеси. Однако на практике скорость этого потока может оказаться недостаточной для транспортировки крупных песчинок, что приводит к их накоплению над насосом. На поздней стадии разработки месторождения при высоком пескопроявлении и периодических остановок скважины необходимо учитывать осаждение частиц не только в покоящей жидкости, но и в движущем потоке. Скорость осаждения частиц в неподвижной жидкости определяется вязкостью среды, гранулемическим составом и концентрацией песка. В этом исследовании для определения размеров частиц используются размеры, которые были определены методом визуального сравнения, впервые предложенные Уильямом Крумбейном и Фрэнсисом Петтейджем в их фундаментальной работе «Руководство по осадочной петрографии». При низком содержании песка жидкость можно считать условно бесконечной, а осаждение частиц – это независимым, то есть без взаимного влияния частиц друг на друга. На оседающую частицу действует сила тяжести, трение об стенки трубы, межслойные трения и другие силы. Сопротивление движения, в частности, зависит от скорости потока и режима течения, то есть ламинарное либо турбулентное, которое может измениться по высоте насосокомпрессорных труб. В обтекании частиц характеризуется коэффициентом сопротивления, зависящим от числа Рейнольдса. Ввиду недостаточной изученности влияния режима течения на процессы седиментации, расчет сопротивления обычно выполняется по эмпирическим зависимостям. Следующий. Next. В этой работе мы рассматривали силы, движущиеся на песчинке в потоке, силы тяжести, силы Архимеда на силы трения, зависящие от вязкости нефти и диаметра частиц, а также некоторые формулы для расчета сопротивления среды в зависимости от режима течения, ламинарный, переходный, турбулентный, и числа Рейнольдса, которые помогают нам определение режимов. Следующий. Next. В этом слайде здесь мы указали как бы графики зависимости от разных физических параметров. Первый график это у нас первый график показывает, что с увеличением плотности нефти наблюдается слабая тенденция к росту времени сожжения, особенно для мелких частиц песка диаметром от 0,5 мм и менее. Это связано с уменьшением разности плотности между средой и частицей, что снижает результирующую силу тяжести, способствующую осаждению песка. Следующий график зависимости это демонстрирует, что ярко выражена зависимость с ростом вязкости нефти, особенно при увеличении до значения от 0,6 с времени 0,6 паскаль в секунду с времени sedimентации вырастает. Более крупные частицы оседают быстрее, однако даже они показывают замедление при увеличении вязкости. Третий график зависимости показывает, что скорость осаждения увеличивается нелинейно с ростом диаметром песчинок, но резко уменьшается при увеличении кинематической вязкости среды. Next. В заключение вот этих графиков зависимости можно сказать, что для крупных частиц требуется высокая скорость потока для предотвращения их осаждения. В этом слайде у нас предоставлена логарифмическая диаграмма, демонстрирующая зависимость скорости оседания частиц от их диаметра в различных гидродинамических режимах потока. У нас 3 режима, как я выше говорил, у нас имеется, мы рассматривали 3 режима, как ламинарная, переходная и турбулентная. Здесь, в этом графике, можно увидеть, что скорость осаждения, оседания либо возрастает пропорционально квадрату диаметра частиц согласно закону Стокса. Это область, где вязкость жидкости оказывает доминирующее сопротивление. И поведение частиц хорошо описывается аналитически. Следующая область – это у нас переходная область с ламинарного до турбулентности. В этой области зависимость между скоростью и диаметром усложняется, и поведение частиц становится менее предсказуемым. Здесь используются как раз такие эмпирические соотношения сопротивления. Третье – это у нас область, турбулентная область. Здесь сопротивление среды возрастает нелинейно, скорость осаждения практически не зависит от вязкости, а коэффициент сопротивления стабилизируется. В этих условиях осаждения тормозятся турбулентными вихрами, и точнее моделирование будет учета инерционных и геометрических характеристик частиц. В конце можно сказать, что этот график позволяет нам оценить критические условия, при которых частицы остаются во взвешенном состоянии или начинают интенсивно оседать, что важно при проектировании оптимальных режимов работы насосно-глубинных оборудований и предотвращает образование песчаных пробок в самом насосно-компрессорных пробах. Следующим. Next. Результат приведенного исследования подтверждает, что седиментация песка в скважинной жидкости оказывает критическое влияние на стабильность и эффективность транспортировки продукции при эксплуатации глубинно-насосного оборудования. Ключевым факторами, определяющими интенсивность осаждения частиц, является вязкость самой среды жидкости, то есть плотность и скорость потока. Учет этих параметров позволяет минимизировать риски образования песчаных пробок и преждевременных отказов насосного оборудования. комплексный подход к управлению процессом седиментации через улучшение режимов работы, выбором защитных средств либо устройств и контролем самого гидродинамических характеристик самого жидкости позволяет повысить надежность системы в транспортировке и продлит ресурс работы нефтепромыслового оборудования. Спасибо. Следующее. Спасибо за внимание. Вопросы? Прошу, вопросы.
No questions from the. Thank you very much.
Thank you.
Okay, so we will move on to the last presentation in this section, which will be presented by Anna Urbane. And the title of the presentation is Dynamic Society-Oriented Total Cost of Ownership Model for Electric Bus Deployment.
Hi, good morning, everyone. My name is Anna Urbane, and I work at the Department of Transport at University of Economics in Katowice. So my main of research is transport economics. And today I have this very difficult role to present the results of our study about the deployment of the model. So presenting the model is always a little bit problematic, of course, and I have a difficult role because I'm the last presenter before the coffee break. So so I'm aware that everyone is waiting for the coffee break. So I will try to speak shortly and be precise. So yes, the topic of the presentation is dynamic society-oriented total cost of ownership. So it is the quite holistic approach to evaluate the investments in battery electric buses. Of course, this is a well-known problem because many cities worldwide invest in battery electric buses, so it is a quite well-known problem. Of course, there are many advantages of these buses, like they contribute, of course, to sustainable urban mobility because they are locally emission-free, and of course they are the most effective in the high density populated areas. Of course, they are only locally emission-free because it depends on the energy mix. We are all aware of it. But of course, a lot of advantages of such buses in cities for citizens. But of course, there are a lot of challenges for battery electric buses deployment in cities. We have a lot of issues connected with the extraction and disposal of materials used in electric vehicles, of course, mostly connected with charging with batteries. Of course, so we need to have a proper evaluation of the energy mix and battery life cycle. So it is quite problematic because nowadays we don't have enough knowledge about it to solve a lot of problems connected with it. Of course, we have some problems connected with limited branch and charging. So there is always a problem for public transport operators to select the correct type of bus, the correct type of battery park, the correct route, and to solve a lot of organizational problem with charging. So of course, also estimating energy consumption and select optimal charging strategies, which is not it is not simple, especially in this when we have a city with some kind of mix of density. So it is the most effective in high density, but when we have suburbs, it is of course problematic. And of course, we have also some cost consideration, like because the battery electric buses are as twice as expensive as conventional buses. So it is hard to plan the investment without any subsidies, especially for local authorities or regional authorities. And there are some concerns, of course, about external costs, because very often and in majority of analysis there are overlooked. So a lot of challenges with this cost consideration, and of course there are also organizational challenges, like as I said before, as I told you before, to choose which route will be appropriate, and of course to include the financial factors and total cost of ownership, which is not, although it is a well-known methodology, it is not so widely used, especially in public public transport by public transport operators. So these studies play a crucial role in the decision-making process. And a few words about this TCO, so total cost of ownership methodology. It is a well-known and methodology widely used in transport to assess the full cost of vehicle deployment, of the infrastructure investment also. And it goes beyond the purchase price, considering all ownership related costs in the whole life cycle of the investment. So it is very important. And many studies rely on very simplified assumptions and fail to account for all these costs, and that's why this decision process is, I would say, not so fact-based, let's say. So it is important to include all these costs in the whole life cycle. And of course, there are some problems in the previous studies. We have some lack of consideration for other investing models, like loans, subsidized, etc., etc. It is included in our model, and as I told before, also external costs, so connected with carbon emissions, with pollutant emissions, and very often they are overlooked in traditional TCO models. So we have also static and dynamic models. So static models, so they assume a constant value of money, but nowadays they are rarely used. And dynamic models, our model is dynamic, so use net present value and includes also some cost forecast for future expenditures. And we have two main approaches to build TCO models. The first one is consumer-oriented TCO. So it focuses only on costs perceived and borne by consumers, like purchase price, operating cost, etc. And the second one, which is society-oriented TCO, it is a much broader approach. It includes external costs and all these, in addition to capital and operational expenditures. So our model is designed to facilitate the ex-ante evaluation of the long-term cost, evaluation of long-term costs associated with our investments. It is a multi-stage process with comprising three main components. Input data, we have here all the parameters of buses, parameters of battery packs, energy consumption, parameters of charging infrastructure, maintenance cost of infrastructure, and parameters related to bus schedule and bus assignment vehicle cycles. And then we have these processing algorithms that include all these parameters connected with all economic analysis parameters, rates of changes, time, and the funding structure. So general cost and external cost, and as an output we receive we can receive disaggregated disaggregated costs. So we have cost per category or just in time interval, and aggregated indicators. So total TCO or TCO per vehicle kilometer. The key element of the dynamic society-oriented model, our model is of course the methodology of present value. So we are based on the present value. In a quick short, just the general, in general, how the model looks like. It is quite simple. Because it consists, of course, the present value of all the main components, like buses, like infrastructure, external costs, and operating costs. And we have this possibility to cooperate because the model was developed under the project, international project financed by under the IRANET. It was Platon. In the end, I will show all the references to this project and the website to visit and to test all these components. But of course, we have a opportunity to work with public transport operators here from Poland and from other European countries, and to test it in business practice, let's say. So here for the paper, we have some basic assumptions like different financing structures, funding structures, different the purchase of buses and infrastructure some batches because it was a long term. So it is based on the real assumption from the real business practice given by public transport operator. Actually, these one are from Polish, operated from the south of Poland. So of course, different assumptions like battery replacement and disposal every 5 years, etc., etc. So assumptions, and to test how does it look like in practice. And here we have the first one, which is without subsidies, and the same model on the second figure with subsidies. So the only difference is subsidies to look how it will change, or it does how does it look like in the long term. And actually, what is the most important here is the structure, because these figures, these models are almost the same, but the difference is how it is perceived by public transport operators, because very often it is perceived. They perceive the purchase such investment like the biggest cost is the infrastructure and the purchase of buses, but it is not true. Because actually, of course, in the first year it is the main the biggest element, but in the later in the structure we can see that operating costs and external costs are really huge, and they are dominating in the structure. So it allows to look at the real cost in the long term, in the long term perspective. So we can see that the structure, of course, is changing, and of course, with subsidies, it looks fantastic, because in the first year the cost for the public, for the investor, actually are not so big, but we need to take into consideration the whole process to see the real costs. So as an input, of course, we can receive okay. Oh, it's okay. So we can here It is a little bit small for this group, but we can see, of course, the numbers in the table, but we can receive the aggregated TCO for 30 years in this case, and we can see also disaggregated TCO in euro per vehicle kilometer. So the difference is we can see the difference between models, but actually the real value is in how it look like in the whole 30 years of analysis. So conclusion. So of course it is ex ante economic evaluation. So it is important at the beginning, before the investment, actually to check and to decide what will be the whole process of conversion of the fleet in our company. Gradual deployment of electric buses aiming for broad adoption, often over many years and in phases for economic reasons, of course. So it is good to plan it as in stages. Of course, it is important to include external costs or other climate-related costs or other pollutions, or of course, costs according to other pollutions. Our model also allows us to allocate the cost between stakeholders. For example, between not only the public transport operator as an investor, but also local authorities. For example, if they participate in the financing of the investment, because of course there are different models of integration. There are different models for financing public transport. So it is important also to allocate some costs to other stakeholders. Of course, it is important to include these dynamics of cost changes, especially taking into account inertial costs, which are very dynamic nowadays, and to include it. Of course, the inflation is included also in the model, and of course, to include different financing models to be useful for public operators worldwide. Of course, this all helps to reduce financial risk for transport operators investing in innovative technologies. So main components, once again, so operation and maintenance cost over 60% of the total cost of ownership. External costs more than 1/3 of the total cost of ownership, which is quite a lot. Yes, so we are very often not aware of it, and maybe we think that it's a little bit counterintuitive, but it is the truth about also the investment. So we need to know all these components, and infrastructure costs, which are the smallest share in the TCO structure. So these external costs were not considered in previous models, so it's crucial in this methodology, and highlighting the importance, of course, in the TCO calculations. And different funding mechanisms, such as shared infrastructure cost between operators and authorities. And we can say, of course, that these detailed TCO models provides very valuable insights for all stakeholders in the market. And of course, the model later allows for sensitivity analysis. So let's say it can be the first step, and the second step is the sensitivity analysis of cost parameters for future cost dynamics. And the paper is based on the TCO model developed as a part of the research projects, Platon, which was funded by Polish agency, National Center for Research and Development, under the Iran program. And it is also possible to visit the website. There are a lot of components in the project, but I was responsible for this economic part, transport, total cost of ownership. So it is possible also to visit the project website and to test all these components. And that's all. Thank you for your attention. Thank you, Anna.
Okay, do we have any?
Any
no
questions
question.
can be at our coolers.
Okay.
Yes, because we have the time now for our coffee break. And only my small information for you, because some participants asked me about certificates of participation. Today, for all participant of our symposium, can take these certificates after the finishing of our last fourth session. Some person, some participant which participate using internet in online regime, all take own certificates by normal mail. This is understandable?
Yes.
Okay, now we have some break for coffee.
Thank you.
Please, thank you, our chairman.
Thank you very much.
Okay, let's go. Yes, push your back.